Well, this is getting a little more interesting. Multiplying polynomials. Multiplying. Multiply any two polynomials, we'll be able to do that. Of course, the fewer terms they have, the easier it is. Multiply two binomials by the FOIL method. We know this. We have a binomial here. Let's say it's x plus 1. And we have a binomial here. Let's say it's x minus 2. The FOIL method says we multiply the first two by each other. That would give us x squared, wouldn't it? And then we multiply the outside terms by each other. So we'd have x squared, and we'd have a minus 2x. Then we do sort of a breaking point right here. Then we do the inside, where we say, we've got a plus 1. I know we don't usually write it. I'm just doing it for fun. And then a negative 2. And we add all of that together, and we have the product of those two binomials. Multiplying two binomials by the FOIL method. Squaring a binomial. Oh, sure, we know that. If we have x plus 1 squared, it's the same as saying we have x plus 1 times x plus 1. And to keep us out of trouble here, we could use the FOIL method, couldn't we? Now, we don't have to if we recognize the pattern, but I kind of like it because it keeps me out of trouble. And I'll tell you what trouble we often see with squaring a binomial in just a moment. Notice I didn't write the 1 this time. 1 times 1, x squared, plus, because the multiplication of the outside and the multiplication of the inside are always exactly the same when you're squaring a binomial, I always get 2 times the product of x times 1. The problem we often see, you've probably done it yourself at least once, doing this, is we immediately understand that we need to square the x. So we do the x squared. We immediately understand we have to square the 1. But what do we forget? We forget what's in the middle here, that we still have to do the outside times the inside. Well, the pattern we use, if we don't want to bother writing all this out, is to say, okay, I know it's going to be x times 1 twice. So 2 times the product of these two terms. It's a little shortcut. But please don't forget the middle. Please don't forget it. It's so important. Multiply the sum and difference of the same two terms. Oh, yes. So sum and difference. So the sum of x plus 1. Okay, so the sum of x and 1 times the difference. And what do we call this particular pair of factors? These are conjugates. When you have the same two terms set up as binomials, the sum and the difference, then you have conjugates. It's a very nice thing that happens when you sum these to, when you multiply these together. First and the outside give us x squared plus x, and then the second half of this. The inside, which, oh, wait a second. Sorry about that. When we multiplied this together, we didn't get a positive, did we? How silly of me. No, x times a negative 1 gives us a negative x. Now I do my positive. I get a positive x for my inside. And then the last is a positive times a negative. And I get x squared. And what happens when I add these two up? They zero, right? A plus 1 and a negative 1, 0, minus 1. We know this as the difference of squares. So the difference of squares is a product of conjugates. And conjugates are the sum and difference of the same two terms. This is going to be so useful to us going forward that it really is worth making a note of this. Cubing a binomial. Oh, we're going to spend some time on that. Let's get moving here. I haven't even started and I've already got you over 6 minutes in. Could we simplify this one? All right. So we have any other terms that look like that? Yes, we do. And these two. So we definitely could. We'd get a 3 of these and 8 of these, right? Could we multiply these two factors? Here's one factor and here's another factor. Now granted, it's a fancy factor, but because it's in parentheses, it is, when you look at the whole thing, it is a factor. It's a binomial. We're going to use the distributive property here, which will give us 25x plus 20. Now on this one, I have this factor and this factor. I do not have inside my parentheses any pluses or minuses. This is making it very easy. I'm going to just organize these. I'm going to use the associative property here. I'm just going to organize these a little differently. So I'm going to say 3 times 2. So I put the numbers, my 0 power numbers here. And I'm going to have x to the 4th times x to the 3rd. You see, I'm simply organizing them so I'm matching bases. It's wonderful. I do not have to worry. No worry about like terms. Why not? Because I'm not adding and subtracting. That's a concern I have when I'm adding and subtracting. When I'm multiplying, I'm looking for, look for like bases. Like bases. All right, like bases. The different exponents are not going to be a problem here. I've got y to the 2nd and y to the 6th. Now you remember from our study of exponents that if we have the same base, what can we do with their exponents? We can add them. That's why I was emphasizing like bases. So we end up with 6x to the 7th, y to the 8th. Multiplication of binomials. Multiply any two binomials. Any two polynomials, I'm sorry. These happen to be binomials. And how could I look at this? I could say, well, I am distributing this factor right here. I'm distributing it to my x and to my 1. I'm multiplying. And this is kind of a different way. I'm not foiling, am I? I'm using the distributive function. And then I end up with this term and this term. Now at this point I think I would use the distributive function, wouldn't you? I'd say, okay, multiply the -1 times each of these and multiply the x times each of these. I'd love to show you maybe a little bit different way of thinking about these problems. And when I do that, this is what I get. Now that still looks rather messy. So I'm going to clear out these parentheses. This isn't needed. And this, when I'm adding a negative, it is a negative. Adding a negative, it is a negative. Now what's my chore? Combine like terms, which are these two. A +4 and a -2. So I didn't FOIL. I used the distributive property first, and then I used it a second time so that I got everything multiplied by everything. Then I looked for like terms and simplified. Done. The reason I did that is because we do get into this situation here where FOIL no longer works. It isn't two binomials, it's a trinomial and a binomial. So I want to rearrange it a little bit. I'm not wanting to distribute this, and I like to think of what I'm distributing on this side. Even though back in this problem I was going like this, I still prefer going this way. So what do you suppose I'm about to do? Yep. I'm going to take, considering this as a factor, distribute it to each term within this parentheses. And that's what we get, right? This factor times the first term plus this factor times the second term. And notice the second term is negative. And then this factor times the last term. Now what do I do? Just as I did before. Distribute those back. So in the end, I have multiplied every factor by every other factor. There are other systematic ways to do this. Just keep in mind what your goal is to multiply every factor here by every factor here. And it can get, of course, as you can imagine, more and more complicated as you have larger and larger polynomials. There's a result. Then I remove the parentheses. The only place that might have been a little tricky was right here, but we know how to handle that. And now I look at this and I look for opportunities to simplify. So do I have any terms that are the same? Yes, I do actually. Right? A square B. So this one, this is another a square b. And I have 2ab square and 1ab square. So I've got this one and this one. Let's put them together. I get 2a to the third minus 4 minus 1 is minus 5. Then I have a +2 and a +1, so I have +3 of these creatures. So that's what I should do to simplify it as much as I can. Multiplying two binomials. We can FOIL, right? We can FOIL, or we can, well, let's look at this one. We can use this process of distributing one of them to the other and then working out the final distribution after we've done that. Or what's the other thing we could do here? Yes, of course we could. Oops. We could FOIL first, outside, inside, last. First, outside, inside, last. First, outside, inside, last. Nice systematic way to do two binomials. Squaring a binomial, well, you've got choices here. If you memorize this pattern, you're going to be able to move very quickly when you see a binomial squared. You'll be putting it into what we refer to as a perfect square trinomial. This can be so useful in a testing situation to have memorized this. So that would be, you square the first term, you square the second, which is a -3, isn't it? So that would become a +9. And we never forget that we have a middle term. And the middle term, its sign will come from the sign in the middle of your binomial. It's going to be a negative. And we've got 3 times x twice, right? Twice the first and the second member of the binomial. Twice 3x is 6x. Of course, we know it's negative. How about this one? Can we apply the same logic? We're going to square this first term. Remember, when I square the first term, I am not just squaring x, am I? So I get 9x squared, and I square the last term. By the way, when you're squaring a binomial, this third term here is always positive. Why is that? Because when it's negative times negative turns positive. All right, and this will be 16y squared. But we are not done, remember? We've got a middle term. It's going to be twice the product of this and this. 4y times 3x gives me 12xy. Twice. Let's do this one. Now this one is getting a little more complicated, isn't it? We've got 2x squared, and we're going to square it, which means we multiply it times itself. If you suspect you may be in a situation that you might miss something, go back to the basics. Take the time to write them out. And I know if I am squaring this, that what that means is right down here. And when I have it written out this way, it becomes a lot clearer, doesn't it? 2 times 2 and x squared times x squared is clearly 4, same base, right? We add the exponents, x to the 4th. So I just squared this term. Now let's square this other one. It has its own complications. I know it's going to be positive because it always is in a squared binomial. Or I could work it out and I'd see that it was. And that's x squared y squared. When you're squaring a whole term, everything in it squares, including the -3. Now, I know that this is going to be negative because it always matches this, and I could prove it as I work it out. I'm going to take the first term and the second term, multiply them times each other, and then double it. All right. 2x squared times 3xy. Ooh, I think I'll write it out. 2x squared times 3xy. I'm ignoring the negative at the moment. That's the same as 2 times 3 times x squared times x times y. And remember, when we have the same bases and we're multiplying, we add the exponents. We haven't written it out, but we know this is 1. So that's 6x cubed y. And we have to double it. So that's minus 12x cubed y, squaring a binomial. Product of conjugates. I love conjugates. Why? Back here when we square a middle term, we had to spend quite a bit of time, didn't we? I mean, the hardest part of it was finding out what this middle term was. Please don't forget this. I consider that a big problem. I'm warning you about it. I'll take off a lot of points if you forget the middle term when you square a binomial. However, if you have conjugates that you're multiplying together, we can forget the middle term. The reason we can do that is back here. And then we look at that right at the beginning. These are our conjugates. And when you, let's say you FOIL them out, which, by the way, is a good thing to do if you are thinking, I'm not sure I remember just how that works. Go back to the basics, FOIL them, and you'll see that what might have been your middle term, a negative x and a positive x, cancels out. That's always true with conjugates. No matter how complicated the conjugate is, thank goodness it's always true. So we end up just having to do a difference of squares, and it's x squared. Now, difference of squares, it's always going to be negative because we always have this situation of plus and minus. That's so quick and easy. No need to consider the middle term as long as you recognize that you have conjugates. And this becomes 9x squared y squared minus 16. Oh, could I see this as conjugates? Remember that that has to be in this form. Two binomials, one as a sum and one as a difference. Well, there actually is a way I can think of this as a product of conjugates. I think of this as the first term. So I say, okay, my A equals 2x plus 1. And my B, oh, is that going to work? Plus y minus y. Oh, yes, my B equals y. In which case, what do? I square whatever my A is. I square my A, and it's a difference of squares. I square my B. Now, I'm not finished. Conceptually, I'm done, but I actually am not finished because don't I need to multiply that out? Let me FOIL it. Now, we just talked about this. This is a binomial being squared. So it's 2x plus 1 times 2x plus 1. We know the shortcut for this, don't we? We square the first. We square the second. And then we take the product of the two of these, which would be 2x, and double it. Or we can do this. Say 4x squared first outside plus 2x. Now we do the inside plus 2x. See how that happens every single time with binomial squared? And then we do the last. And it's 1 times 1. Add them together. So either use the pattern, or if the pattern escapes you, or you're not confident with it, go ahead back to foiling. Cubing a binomial. Woo-hoo-hoo! You can work this out, or you can memorize this pattern. I love this pattern. Please notice this. We've got our a's. We're just going to, at first, look at our a's and what happens to them. A cubed, a square, a to the first power, whoop, a to the 0 power. Let's see what happens with our b's. In this case, b to the 0 power, b to the first, b to the second, b to the third. So as this one is declining, the b powers are increasing. What else do we notice? This has a coefficient of 1. This has a coefficient of 1. And right here, a 3. A 3. So if we're adding, everything is positive. If we are subtracting, the second term is negative, and as you would expect, the last term is negative. So it's positive, negative, positive, negative. I recommend this. Let's use the pattern. We have it in front of us. We're going to cube A. We're going to cube B. And unlike squaring an even exponent, we actually could carry over a negative. In this case, it's going to be positive. Now, there's something interesting happening here. It sort of reminds me of when we were squaring a binomial. We could be sure of this and sure of this on either end, and then we had to worry about what was in the middle. With cubing, you've got 2 terms in the middle. So it's going to be a squared times b, and 3 of those. And then we're going to have a times b squared, and we're going to have 3 of those, and everything's positive. Let's try this one. All right, I know I square my square, guess not, cube my first, cube my last. What happens when I cube -1? Odd exponent, I'm still going to have a -1. I'm leaving myself plenty of space. I know I've got 2 terms to get in the middle. I also know that this one is going to be negative, and this one is going to be positive. So let's see what happens. It's going to be a squared b. So x squared times 1. Oh, that's simple enough. X squared. And I'm going to have a 3 here. And now I'm going to do x times 1 squared. So there it is, using the pattern. Oh, now something a little more challenging. Okay. First part we can do quickly. We get our first. Oh, no, 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 I'm cubing, aren't I? What did I do? I squared this thing. So I want to cube my 2, which would be an 8. Don't fall into that trap. And cube my x. And then over here, cubing 3. Ooh, there's a lot to think about. 27 and y cubed. So I could do the first and the last. Now I'm going to work on the middle. And what do I know? That it's going to be positives. And let's see, what do I have to do? I have to square my first term, so that's going to be 4x squared. And the second term I just use as it is, 3y. Well, that will simplify, won't it? To 12x squared y. And then what do I do? Then I have to multiply it times 3. So I end up with 36. See, this gets very interesting. Now I'm going to do my second middle term, which is going to be ab squared. My a is 2x. My b is 3y, and that's going to be squared. Yeah, so I get 2x times 9y squared, which is equal to 18xy squared. All I dealt with just now, though, was here. I still haven't multiplied it by 3. When I multiply this by 3, I'm going to get 54. Woo! Get into big numbers fast when we start cubing, don't we? So, cubing a binomial. Memorize those patterns.